Hi guys, welcome back to the Core Learning channel. Today we're going to be looking at graphs and we're going to be looking at straight lines and gradients. So the objectives for today, we want to understand the basics of straight line graphs, what the gradient of a line is, and how to write the equation of a straight line.
So the first thing that we need to do here is have a basic understanding of our graph. Just in case anyone is wondering, I'm using a graphing calculator from Desmos. I'll include a link in the description below. This is a really great tool to help you plot graphs, so if you are struggling, I recommend you have a play around on here. Going back to where we were though, one of the key features of a graph are the axes. So we have our y-axis here, which goes up and down or vertically, and we have our x-axis, which goes from side to side or horizontally. Now generally we call these x and y, but the axis could represent any value of something. So we could have one axis which measures somebody's weight and the other axis which measures their fastest running speed. Or we could have the age of people as an axis and their salary on the other axis. Now, given the graph is written in the standard way, I like to think of our x as a width and y as our height. So I'm going to plot a line here. I'm going to plot the line y equals 5. So this is saying we want a line which has a constant height of 5. So you can see here that this green line runs at the same height no matter what value of x we have, or we can go side to side in any direction and the height of the line is always constant, it's always 5. Likewise, if I were to plot the line x equals 2, now we can see that this is a line which has a constant width of 2. Doesn't matter how far up or how far down you go, the width is always 2, or the x value is always 2. Now, there is another type of line that we can also look at. This is a complete diagonal line. So this is the line of y equals x. Now, this is a line where for every value of y, the value of x is identical. So the coordinates that this line would pass through would be the coordinates y equals 1, x equals 1, y equals 2, x equals 2, y equals 3, x equals 3, and so on in the positive direction, and the coordinates minus 1, minus 1, minus 2, minus 2, and so on. You get the picture. There are also other straight line graphs which are not vertical or horizontal, which we're going to take a look at now.
So I think the easiest way to think about the gradient of a straight line is that for every 1 unit of x, we want to know how many steps of y do we take. So this is my 1 unit of x, and now how many steps of y do I have to take to get back to that red line? And we can see here it's 2. So in this case, our gradient, which is represented by the letter m, is going to be equal to 2. Again, we're going to take 1 step in the x direction. How many steps do we need to take to get back to the line? Well, it's 0.5 in the y direction, so this is going to be our gradient. The last one here, so we take 1 step across, and now this time we take 2 steps down, so this is -2. So our gradient here is m equals -2. So we have a concept of what the gradient is, but we need a consistent and reliable way of calculating the gradients of straight lines. So the way we do this is we identify 2 coordinates on our straight line like we've shown here and write them out. So we've got our x2, y2 and our x1, y1. Now the gradient is the amount of change in the value of y for a given amount of change in x. Now here I've written this using this fancy math symbol. Try not to be afraid. So this triangle symbol that you can see before the y and before the x, this is the Greek letter delta. Now in maths, a delta just means change. So all it means
Don't have to be terrified of this. So delta y means a change in y, and delta x means the change in x. Therefore, the change in y is going to be the difference in height between our two coordinates, and the change in x is the difference in width between our two coordinates. So this is represented in that equation by the y2 minus y1 and x2 minus x1. So using this equation, we can work out the gradient of any straight line. So now let's actually look at the values of these coordinates. So our top coordinate has a coordinate pairing of 1, 2, and the bottom coordinate is 0, 0. So we're going to plug these values into our equation and we get a gradient of 2. So we're now going to do some practice questions on working out the gradient of some straight lines. So for question 1, we have this straight line. What we need to do is pause the video, and using the method we just ran through, I want you to try and work out what the gradient of this line is going to be. So first, we're going to plot our two coordinates here. So I'm going to choose these 2 points as our coordinates, as these fall on nice coordinate values, so integer values. So the first coordinate pair is 1, 1, and the second coordinate pair is 2, 5. So now we need to plug these values into our equation. So plugging these in, so our y2 is going to be 5 and our y1 is 1. So y2 minus y1 is 5 minus 1. And then our x2 is 2 and our x1 is also 1. So this is going to be 2 minus 1. So we have 4 over 1, which equals 4. So we have a gradient of 4 here. So here we have our line for question 2. So here, again, I've chosen some integer coordinate values. So we've got this point 0, 2 and this other point 1 minus 1. And when we plug this into our equation, we're going to get a gradient of minus 3. And now we have our last question. And so here I've chosen the coordinates 0, 2 and minus 5, 0. And I'm going to plug this into my equation and I get a gradient of 2/5. So we hopefully now have an understanding of the gradient of a straight line, but we're not quite ready to start plotting the equation of a line yet. You can see here that I've plotted 3 lines, all of which have the same gradient, m equals 2. However, we can see that they are clearly not the same line. The difference between the lines is where they cross the y-axis. Now, if you look at the top, where you can see I've plotted the equation of the straight line, you might be able to notice that this term on the right-hand side of the equation, next to the x, actually represents where the line crosses the y-axis. So you can see we've got y equals 2x plus 3, and we can see that the line crosses the y-axis at the point 3, and for the next one at plus 1, and for the last one at the value minus 1. So as such, it may not surprise you to learn that this term on the end is known as the y-intercept. So to write the full equation of a line, we need both the gradient of the line and the y-intercept. So what I'm going to show you here is how we commonly represent the equation of a straight line in its most general form. So this will be y equals mx plus c. So what this is, it says our value of y is equal to the gradient applied to x plus the value of c, which is this y-intercept. So now we want to know how we're going to find the equation of a straight line. Well, the first step is actually what we were doing before. So this is that we need to find the gradient of the line. So we know how to do this. We take our 2 coordinates, and I'm not going to go through the whole step, but the gradient here in this particular example would be 3. So what we do now is we're going to plug this value that we found into our y equals mx plus c. So remember the gradient is represented by the m. So we replace the m with 3 and we get y equals 3x plus c. Now what we're going to do
is we can find any coordinate on the line. Now, again, I always recommend if you're asked to find a coordinate and you can choose anything, just choose a coordinate that has nice integer values. So here I'm going to choose the coordinate 1, 5. Now what we do is we're going to substitute these coordinate values into our y equals mx plus c. So we've got our y, we've got our x, we've got our m, it's only our c that we need to find. So plugging this in, our value of y is 5, our value of x is 1, our value of m is 3, so we have 5 equals 3 times 1 plus c. So now we just need to rearrange the equation to find the value of c. So rearranging this, we get c equals 5 minus 3 times 1. So 3 times 1 is 3, so 5 minus 3 is 2. So our value of c is 2. And now we have the values we need to write this equation, which is m and c. So we're going to substitute our m and c into this general equation y equals mx plus c. So we've got an m of 3 and a c of 2. So the equation of this straight line is y equals 3x plus 2. So now we'll run through some practice questions for finding the equation of a straight line. So have a go at finding the equation of this straight line, and when you're ready, unpause the video and we'll go through the solution. So our step 1 here is going to be that we want to find the gradient of the line. Now, I'm not going to go through the whole process, but the gradient here that you get should be 4. So the next step now is we're going to plug this value of m into y equals mx plus c. So we get y equals 4x plus c. Now we're going to identify a coordinate on the line. So I'm going to use this 1, 2 coordinate. I'm going to substitute these values of x and y into y equals mx plus c. So this becomes 2 equals 4 times 1 plus c. I'm going to rearrange the equation to find the value of c. So we get c equals 2 minus 4 times 1, which equals 2 minus 4, which is minus 2. Then our last step is we're going to write out this with our values of m and c. So the equation of this straight line should be y equals 4x minus 2. And now we have question 2. So here, I'm just going to display this all at once. So the gradient of our line here is going to be m equals minus a half. We now plug this value of m into y equals mx plus c to get minus a half x plus c. So the coordinate on the line that I chose here is the coordinate 0, 1. So we're going to plug these values of x and y into our y equals mx plus c. So we now have 1 equals a minus a half times 0 plus c. Rearranging this, we get the value of c. So we get c is equal to 1 minus a half times 0. Sorry, that's 1 minus a half times 0. So anything times 0 is 0. So this is 1 minus 0, which is just 1. And now we can write this out as we have our values of c and m. So we have y equals minus a half x plus 1. And now for the last practice question. So here we have a gradient of m equals minus 5. So we get y equals minus 5x plus c. We then find a coordinate. So I've chosen 1 minus 1. And we're going to plug these values in. So we get minus 1 equals minus 5 times 1 plus c. Rearranging this, we get that c is equal to 4. So we have c equals 4 and m equals minus 5. So our equation of this straight line is y equals minus 5x plus 4. As always, thanks for watching. Hopefully you enjoyed the video and learnt something today. If anything is unclear or you have any questions, leave a comment and we'll get back to you as soon as possible. If you haven't already, please like and subscribe, and we'll see you at the next one.